Hey everyone, welcome back to the series. So today we are going to discuss about a next video in our lecture series, that is Internet of Things. So until we have discussed about many routing protocols which are used in basically the Internet of Things, like 6LoWPAN and HTTP. So those are the some of protocols which I have discussed. So if you have not seen those videos, you can check the playlist, so you can find the link for same. So in this video we are going to discuss about RPL. So the abbreviation for RPL is Routing Protocol for Low Power and Lossy Networks. So as its name itself suggests, it is a routing protocol which is specially used for low power as well as lossy networks. So where there is a scenario where the nodes are battery operated and there is a loss of signals in the transmission. So in those areas we have to use this RPL. So I can say this is the modified version of 6LoWPAN. So 6LoWPAN was consuming more power, so that's why this RPL was designed specially in a large wireless sensor network areas where the nodes will be battery operated and they are placed in a harsh environment. So there are more chances of signal attenuation when the signal is transmitting from or it's a in nutshell I can say when the signal is transferring between one node to other node. Alright, so that's about a quick introduction about what is meant by RPL. So the contents which we are going to discuss in today's sessions are we will see what is meant by RPL, and then we will go for a most important topic in RPL, that is DODAG formation, that is destination oriented cyclic graph, so something like that. So we will see that one, how to create a DODAG, and then we will go for a third topic, that is maintenance of DODAG. So it's very important to know the maintenance of DODAG, because you create a DODAG but due to some defect or some reasons a node goes down. So if a node goes down, what should be done? So that comes under the topic DODAG maintenance. Okay, so if you are new to the channel, please guys hit the like button and subscribe the channel, because we will be updating these type of videos continuously and it will be a big support for us as well. So thanks for visiting. Alright, so now coming to the characteristics of DODAG, characteristics of RPL. So the first characteristic which the RPL exhibits is the capability to optimize and save energy. So it should be able to optimize the network in order to save the energy. So as I said, in wireless sensor networks the energy is most important constraint, because the nodes will be battery operated and they are having limited amount of power with them. So if they use large amount of power, then the life of those nodes will be very small. So that shouldn't happen in the wireless sensor network. So let us say you are putting some nodes to measure the forest, so to monitor the forest. So that is what is the temperature, humidity, and light which is reaching at the ground of that forest. So you are deploying large number of, let us say, some 10,000 sensors, and if their life period is very less, let us say 10-20 days, then it becomes very costly and highly impossible task for someone to optimize or someone to implement that one, because the amount which was used to create that network is very high and it is not giving a as expected output. So that's why if the nodes, that is the wireless sensor network components, if they have a higher life or higher life period, a higher time period, then it will be worth of implementing that one. So that's why it becomes very important. Ultimately our aim is to have a nodes with a higher lifespan. Okay, so that's about first point. Then capability to support traffic patterns other than unicast multiplication, that is communication. So the nodes in the wireless sensor network should be able to not only support their own communication data, they should be able to transport the other data which is coming from the neighbors as well. So if a time comes where you need to send the data from your neighbors, then you should be able to do that one. So that's why the node should be capable of transferring the data of their own and the data which is coming from the neighbors as well. And then capability to run routing protocols over link layers with restricted frame sizes. So if they are limited in power, and they should be able to adapt the frame size, so the data size should be changed according to the incoming information. So RPL builds a DODAG, that is destination oriented directed acyclic graph, so that is abbreviated as DODAG, using an objective function. So OF is the objective function which the node will be keeping in mind in order to create a DODAG. So that takes into account several metrics and constraints. Okay, so later we will discuss about objective function and DODAG in detail, so don't worry about that one. So you just note it down. The RPL is using DODAG for creating a path to the different nodes. Then several different objective functions might be used in the same time, so each building its own DODAG. So there is no rule that rule says that only one objective function should be there. So a node can have several objective functions at a time, so it will be taking all of them into account and creating a optimal path for the parent node. Okay, so that's about the characteristics. And now what is meant by ETX? So this is the very important term which is used in RPL. So that is ETX, so expected transmission count. So shows the quality of a radio connection, that is how many times should I probably send a packet to be sure that it is received. So this ETX tells that how many times you should send a particular data or a data packet in order to make sure that it is received by the receiver. So ETX is expected as low as possible, because as the value of ETX increases, the amount of data which is sent will be increasing. So we don't want that one, because we want our data to be transmitted in a smaller bandwidth. So if ETX increases, then high bandwidth will be used for that one. So that's why the ETX is expected as low as possible. And value between 1 and infinity, expected value based on past experience. So its typical value will be between 1 and infinity, that is minimum it can be 1 and maximum it could go up to infinity as well. Okay, so alright, so moving on further, we will discuss about now the RPL terminologies. So the basic terminologies which are used in RPL routing. So as you can see here on the right hand side, it's a graph which shows let me just show you. So this is the graph, that is DAG. So the basic meaning of DAG is directed acyclic graph. So a direct acyclic graph is something in which there is no loop. So as you can see, no loop is formed in this network. So I can say this is a wireless sensor network, so there will be no loop like structure. So each node will be connected to every other node in a unique way. So they are having a particular path for the communication with the root node. So the one which is having on the higher rank is root, and these are the child nodes for that one. So that is the DAG, that is directed acyclic graph. And now coming to the terminologies. So first we will see what is meant by directed acyclic graph. So no cycles will be formed. So as I said, the graph which contains no cycles is called as directed acyclic graph, and the meaning of directed is it is pointing towards a particular direction. So as you can see in this graph, they are pointing upwards, so that's why they are called directed. So they are having a particular direction. Okay, then root, no outgoing edge. So a root is one which has got no outgoing edge. So as you can see, this one it has got no outgoing edge, all are incoming. So this one is coming, this one is, and this one. So these three nodes are coming to this one. So the one node which doesn't have any outgoing node is called as root. Then destination oriented DAG, that is DODAG. So DODAG, that is called as DODAG, and then consists of single root. So a DODAG is a single path from the child to the node, that is root. So this is one DODAG, so it will be starting at this node and it will be ending at this node. Okay, so that is the meaning of DODAG. That is a particular or a unique path between root and the child node. Okay, then objective function. So as I said earlier, objective function is minimize energy and latency. The main objective of any wireless sensor network is to minimize the consumption of energy and reduce the amount of time required for the data transfer. Then rank distance from root using specified objective. So rank of this one is 0 and rank of this one will be 1, and then rank of this one will be 2, rank of this one will be 3. So as you move away from the root, the rank will increase, and as you move close to the root, the rank will decrease. So the rank of the root will be always 0. Okay, then DODAG ID. So that is basically the IP version 6 address of the root. So IP version 6 means 128-bit address of the root. So as we know, the wireless sensor network now it is using the IP version 6 address format, because there will be having a large number of sensor nodes which should be connected to a particular network. So if you use IP version 4, then the addresses will be not sufficient in some cases. So to make those addresses sufficient, we are going for the IP version 6, where we will be having 128 bits, and we can have possible 2 to the power 128 bits of 128 bits of addresses. So that is a huge number, one can guess. Then DODAG version. So coming to the DODAG version, current version of the DODAG, every time a new DODAG is formed, the version of the DODAG is incremented. So this is one DODAG, let us say this is one DODAG, and the one which is on the right hand side is the other DODAG. So I can say, as you can see, there are a lot of DODAGs present, and as a new DODAG is formed, the value, so particular address will be given to that DODAG, and that DODAG, when a new DODAG, another new DODAG is formed, then again it will be provided with the incremental value. So like this, for a particular DODAG there will be a particular address. So that indicates the DODAG version basically. So then goal, reachability goal, that is connected to the database. So the goal means the DODAG should be, that is the node should be connected to the database, and then grounded, root can satisfy the goal. So if the node is connected to the database, or I can say if it satisfies the goal, then it is called as grounded, and if doesn't satisfy the goal, or if it is not grounded, then it is called as floating. So here you can see floating. Then parent, so immediate successor towards the root. So for this node, let us say here the parent will be this one, that is immediate successor towards the root node. Okay, that is parent. And sub DODAG means subtree or rooted at this node. So if this connection ends here, let us say the connection is ended here, then for this is the DODAG where this one will be the parent and this node will be the child for that one. Okay. Now this is the very important slide which I want to discuss. So that is how a DODAG will be formed. So a DODAG means, as I have said, that is destination oriented acyclic graph, where the rank, as I said, for the root the rank will be 0, for next level the rank will be 1, for other next level rank will be 2. So similarly it will be keep on increasing as we move away from the root. So as you can see, for this one, if I consider a particular node, let us say this one, so how a DODAG will be formed. So the information will be passed like this. So it will be passed in this manner. So it will be following this path. It will give the information to this node, then it will forward it to this node, then it will give to the root node. So this root node will be connected to the internet. So I will write here. So it will be connected to the internet, and from internet we will be taking that information into our desktop. It may be laptop or personal use computer, or it is a tablet or cell phone or any digital device you can take. Okay, so this is how a complete system will be working there. So now let us discuss what is meant by floating and grounded DODAG. So we'll see what is the basic meaning of floating and grounded DODAG. So grounded DODAG is something which is connected to the database. So this is the database line which I have assumed, and if every node is connected to this grounded or the database node, then it is called as grounded. And here you can see it is not connected to any database, so that's why it is not a grounded and it is a floating DODAG. Floating means it will be not connected to the parent node. Okay, so that's about the floating and grounded DODAG. So I hope you understood. Then now coming to the next topic, that is RPL control messages. So how the nodes will be interacting with each other, that is how they are controlling the communication between them. So that is very important. Okay, so we will see later what is mean by this new, old, and DIS, DIO, so all those things. Let me just explain you these things, that is DODAG information objective. So it is written as DIO. So what is this? So it is a downward RPL instance multicast. So it will create instances of the DODAG formation, and it will transmit it to the downward. So it will be produced by the that is parent, and it will be transferred towards the child. So that's why it is called as downward RPL instance. And what it will be doing is allows other nodes to discover an RPL instance and join it. So if you want to join a DODAG, then you should be listening to DIO messages. So this DIO message will allow the neighbors to connect with the DODAG. So that is called as DODAG information objective. Basically it will be giving the information about the DODAG. So that's about the DIO. Then coming to the DODAG information solicitation, that is DIS. So link local multicast request, that is the request which is produced by the parent. So let us say a node is present and it will send a request to join to the DODAG. So if you want to join to DODAG, then you will be sending a request saying that, just like asking, do you know any DODAG? So one node is present. Assume that one node is here and it is not connected to any DODAG, and other node is here and this is the DODAG. So this is the DODAG network, and these two nodes are connected to each other and this is not connected. Okay, so at that moment it will transmit a DIS message. So it will transmit a DIS message saying that it will ask this neighbor, hey, do you know any DODAG? I want to join. So it is just like asking a neighbor. So that's the particular scenario which I want to show you. Then destination advertisement object, so that is abbreviated as DAO. Then start at child node and move towards parent node or a root node. So this instance or the message will be starting at a child node, let us say this one here, and it will be moving towards the root node, that is for this one the root node will be this one. Okay, so what will be happening in this one is it will ask the other parent node, that is the one which is in the lower rank as compared to this one, can I join you as a child on DODAG? So it knows that from DIS message this node is connected to the DODAG, and if I connect to this one, then I will be a part of that DODAG, or I will be able to connect with the database. So it will ask the parent node or this node, can I join you as a child, so that I will be connected to a DODAG. And the DAO acknowledgement is the message which is coming from the parent node. So either it can say yes, you can join, you are most welcome, or if there is some issue, that is compatibility issue, then it will say sorry, you can't join me. So that's the information regarding control messages in RPL. So I hope you understood that one. Now we will come to this diagram. So here you can see this is the new, means new node or new sensor, and this is the old sensor which is already connected to the DODAG, let us assume. So first the new node will transmit a DIS message saying that, hey, do you know any DODAG? So this will send a DIO, that is DODAG information objective, saying that yes, I know one DODAG. Then it will ask, can I join you as a child? So it will say, either it will say yes or it will say no, you can't join me. So So there are two possibilities in DAO acknowledgement. So this is how a control message will be exchanged between the new node and the old node to get connected to the DODAG. Then here is the procedure for new node joining DODAG. So this is mostly similar to whatever I have explained previously. So when a node appears, it is switched on or it moves from the given area, it starts listening to DIO message. Basically the DODAG information it will be listening. Then if it receives the such message, it decides which DODAG to join. So if it receives multiple DODAG information, so there are 2 or 3 DODAGs which are present simultaneously, then it will decide to which DODAG which I should get connected. Then if it receives nothing, or if it wants to speed up the process, it sends a DIS message. So it has it is listening to DIO message, but no DIO message has been received for that one, or no DODAG is present in that area. So what it will do is it will send a DIS message saying that I know a DIS. DIS basically says that I know a DODAG, that is I want to become a DODAG itself. So DIS triggers the sending of DIO messages from its neighbor. So due to this DIS message, the neighbors will be sending the information about the parent or the DODAG. Then if still no DIO is received, so now also no neighbor node is able to reply for this one, then it has the choice to become the root of floating DODAG. So now this node will decide to become the floating DODAG, that is root of the floating DODAG, which is not connected to the ground or the database. So start sending its own DIO messages. So DIO means so now it has become a root of the DODAG, that is now it has become a floating DODAG. Then it will connect the other nodes to him, so by sending a DIO message saying that I am a DODAG, so you want to join me or not. So that's about the node joining procedure. Then how to build a DODAG in RPL. So the procedure starts at the root node, that is LBR, basically called as low power lossy network border router, so which is connected to the gateway, or it is connected to the internet. So mainly LBRs can exist in the same network. So many there are a lot of LBRs which will be present in a same network. So a single node cannot handle all the data, so we will be putting many nodes in a that is many gateways in a internet in a network, so that the data is easily transferred to the internet. Okay, then new ICMP v6, that is control message for RPL, will be created. So in that we will be having these messages DIO, DAO and DIS. So the functionality of these I have discussed earlier. Then a note point which you should focus is main objective of RPL is to bring in compatibility with the IP version 6 and reduce power consumption by avoiding loops. So the main objective of this whole discussion or the RPL is to make a compatibility with the IP version 6 addressing and reduce the power. So now this is the picture which shows building of a DODAG in RPL. So whatever here is the LBR, which is a gateway for the internet, and the values here ETX, expected transmission count, so can change over time. So this value can change over time, and average value is used to ensure stability in network. So the average value of ETX will be used to estimate the stability of the network, and goal is object function, that is minimize the ETX, that is minimize the consumption of bandwidth for data communication. So in this DODA or in this network there are let us say some nodes A, B, C, D, E, F, G, H, I, so up to I there are, and the weights which are present on these branches are let us say time which is required for data transmission. So from A to LBR the amount of time which is required is 1 second. So it will be not in terms of second in practical applications, but for sake of understanding I am taking it as 1 in terms of second I am taking. So for this one it is 1, For data transfer between A and B it is 1 second, and between LBR and B it is 3 seconds. So similarly all the paths are having a weightage on them. Okay, so here I missed, so it is 4. Okay, so this is a wireless sensor network, and now we want, if I want to move, it is a sensor here and it has some data to send. So how it will define a path to make the communication between LBR, and that LBR will sending the data to the internet, and that data will be sent to the ultimate user here. So from this to this, how the data will be transferred. So it is very important for us to transfer the data up to LBR. So the LBR will take care of pushing the data to the internet, and internet will take care of pushing the data to the user. So we just want to find out in this one how the path will be found, or how it will be. So either it will be like this, or it will be like this, or how it will be formed. So that is basically the meaning of DODAG formation, that is finding a path in nutshell, I can say. So the first step in this one will be the LBR sends DIO message, that is information about the DODAG to its neighbor. So for this LBR the neighbors are A, B and C. So it will be sending information regarding a DODAG, that is I want to form a DODAG. So link local multicast, so it is sending message to all these nodes, so that's why it is called as a local multicast. And link means it want to connect these nodes with them, that is ABC with LBR, so that's why it is called as a linking message. So nodes ABC receives and handle it. So once these nodes receive the message from LBR, based on object function and other constraints, the nodes will decide to join DODAG or not. So they will be provided, that is the nodes A, B and C will be provided with some object function. So based on that object function they will decide whether to join that particular DODAG or not. So if as the LBR is marked as a parent, so if this LBR satisfy the objective functions of the ABC, then they will join that DODAG and they will mark LBR as the parent, that is they will be forwarding the data to the LBR now. And up to this now the DODAG is formed, that is up to A. So now I have marked them in a yellow color so that it will be understood by the viewer that they are now the part of the DODAG. So up to this the DODAG has been formed. So now DIO timer of node C expires. So the timer which is, so when they will be joining the DODAG, they will be setting some timer, that is for this time period I will be joining as a child for this DODAG. So once assume that the timer for C expires, C sends a multicast DIO message to its neighbors. So now C will send a multicast message saying that I know a DODAG. If anyone is interested, then they can join that DODAG through me. So the LBR ignores it because it is coming from a higher ranked node. So LBR's rank will be 0, and for this one the rank will be 1. So the message which is coming from C will be from a higher ranked node, so that LBR will ignore that one. And now B marks C as an alternative parent. So B will mark C as an alternative parent if due to some reason this path is not existing, or if it goes down, then it can route the data to the LBR through B. So it will be sending to C, then it will be sending the data to the LBR. So that's why it will be marking B as a alternative parent, so C as a alternative parent, sorry. Then E joins the DODAG, marks C as a parent. So now here as you can see, E is in the higher rank position as compared to the C. So that's why E has an opportunity to connect with the LBR through C. So that's why it will connect to the C and it will mark C as a parent. So now E has got connected to the DODAG. So as you can see, the color of the E has been changed, so it indicates E is connected to the DODAG now. The DIO timer of node A expires. So let us say now DIO timer, that is object information timer of A, is expired. So sends a multicast message. So it will follow the same procedure as that of the C. It will send a multicast message to the neighbor saying that I know a DODAG, so if you want to join. So the LBR ignores it as usual because it is coming from the higher ranked node. Then B marks as A as an alternative parent. So note that B already marked C as an alternative parent. Now it will mark A as an alternative parent. So in case when both this path and this path are down, that is 3 and 1 path are down, then at that moment it can route the data through A to connect with the LBR. So that's why it will be marking A as an alternate parent. Then as object function definition, so depending on that object function it will be marking. So now the construction of the DODAG is continuous. So the DODAG is continuously maintained. So what will be happening is, again the B's timer will be expiring. So it will send a multicast message saying that I know a DODAG, if someone is interested then they can join. So C will mark B as an alternative parent, then A will similarly mark B as an alternative parent. Then this D will be connected to the B because there is a path through the B to connect with the LBR. So now D has got connected. So once the timer of E expires, it will do the same thing. It will multicast a DIO message, then it will be received by the I, then it is connected through the DODAG through E. So as you can see, this path will be followed by the E particular I want to say. So because 1 here the weightage is 1, here it is 1 and here it is 2. So 2 plus 1 plus 1 will be 4, but it will not follow this path because that's why I have marked it in the other color. So whatever is marked in the yellow color, it is the path of the or the part of the DODAG. So keep that in mind. So you can see there are some lines which are in a green color, so they are not the part of DODAG, which basically want to say. So as you can see, it is not directly connecting to the LBR through this line because the weightage is 3 seconds here. So if it takes through the A, then it is only 2 seconds. So that's why B will prefer to communicate through A rather than directly connecting or directly communicating to the LBR through the path which is taking 3 seconds. So like this it will be continuously sending the DIO message and a whole network will be established. Now if I want to send the message from H to the LBR, then I will be following this path. So let me just draw it in the other color. So it will be following like this. It will go to this one, and then it will go finally here. So sorry, I was not drawing correctly or neatly, I can say. So it is correct, but it is not neat. Okay, so that's all about the DODAG building and how the data transfer will be happening between different nodes. And now we will go to the next topic, that is DODAG maintenance. So how a DODAG will be maintained. So as you can see, the same scenario is there, but here I am assuming that the connection between B and D is lost. A radio connection will be present and that is lost due to some reason. So I have written some definitions as well here. Grounded DODAG, so as I already said, one which is connected to the database, and floating which is not connected to the database, or the one which is not grounded, it will be called as floating DODAG. Then here is the question, that is regarding DODAG maintenance. What happens if the connection between B and D breaks? So D deletes B from its parent list. So previously the D has marked the B as a parent. Now due to the loss of connection, it will delete the B from its parent list. Then as D does not have other parents, it becomes the root of the floating DODAG. So as there is no alternative parent is present for D, so it will become the root of the floating DODAG, which consists of F, G, H and I as the elements, because they are in the higher rank as compared to the D. Now D sends a multicast message. So what it will do to resolve or come out of that position? So it should not be sitting quite so okay, I am floating, so I will sit like this only. So no, it should not do this that one. So it should try again and again to connect with the actual root or the actual DODAG, that is actual database. So what it will do is, D sends a multicast DIO message, that is information message, to its neighbors, letting them know about the change. So it will send a DIO message to its neighbor saying that I got disconnected from the DODAG. node I has got an alternative parent, that is E, still connected through it to the grounded DODAG. So I observe that I have lost a connection through D now, but anyway I have a other parent, that is E, so which is connected to the ground. So no worries, I will connect to the DODAG through E. So that's why it will mark E as an parent. So as D is not part of the DODAG anymore, I deletes it from its parent list. So I will delete the D from its parent list because it has considered E as its parent. Then what it will be doing is, so as you can see, F does not have any alternative parent, so it stays in the floating DODAG of D. So F is not having any path, so it will stay in the DODAG itself, that is floating DODAG itself, and F sends a multicast DIO message to its neighbors. So F will send a message saying that I want to join a DODAG. So G and H do the same thing and follow F in the floating DODAG. So they are also having no alternative parent, so they will follow the F itself. So now a floating DODAG was found with D being the root. So D is the root, and this one which is colored in red is a floating DODAG which is not connected to the ground. The floating DODAG tries to rejoin the ground. So this floating DODAG, as I said, it will try to connect again with the ground. So I sends an multicast DIO message. So I sends an DIO message saying that I know a DODAG. So D receives it. So D will receive that DODAG, learns that it could join the DODAG through I. So it is sending a message saying that hey, I know the DODAG, if you want you can join through me. Then D will receive that one, and D starts a timer related to I. So D will start a timer which is related to I to connect to that one. The setting of the timer depends on the rank of the node I. So depending on the rank of the I, it will be setting a timer, so whether to set a high timer or a low timer. So D wants to be as close to LBR as possible, so it doesn't want to be as far as possible from LBR, so it will be setting a low timer for this one. So suppose that a radio link is established between F. So a radio link is established between A and F here. So assume that it has got a radio link now. So A sends a multicast DIO message. So it says, hey, I know a DODAG, if anyone is interested then they can join through me. Then F receives it, starts a timer related to node A. So F is receiving that DIO message, and it will start a timer related to A because it is coming from the low ranked node. Then as soon as it comes to know that the timer of node F expires, because it is setting a low timer for that one, F joins the grounded DODAG through A, deletes D from its parents. So now F has got connected with the grounded DODAG through A, and it will delete the D from its parent list, and F stands a multicast DIO message. So again the F will do the same thing. It will send the DIO message, and it will be received by the D as well. So G and H join the grounded DODAG through F. So G and H will be connected to the grounded DODAG, that is LBR, through F, and now D sees that it could join the grounded DODAG through F. So already it has got a timer to the I, but as it is in the higher rank as compared to the D, it will prefer to join the LBR through the F, because the path which is followed to join the LBR through F will be less, or it will be taking less time as compared to the path which is taken by the D to join to LBR through I. So it will taking lot of time. So that's why it will prefer this one, it will not prefer this one. Okay, so it will join to F, and now it is not a, it is part of grounded DODAG, so it is no more a floating DODAG there. So the timer related to F expires, then D joins the grounded DODAG through F. The floating DODAG disappears, that is this one disappears here. The problem was handled without forming the cycles. So that's all about how to form a DODAG and how to maintain a DODAG. So I hope you like this video. Please guys, if you like the content and if you found it useful, little bit at least, so I have made a good effort for this one. So hit the like button and subscribe the channel and share with your friends. Thank you. Thanks for watching.